to present today on behalf of the GNSS analysis team in Geoscience Australia and provide a status update on the Asia Pacific reference frame APREF and the recent efforts we have been making in adopting ITRF 2020. Firstly, just highlighting that we work in Canberra, the land of Ngunnawal and Ngambri people of Australia, and Geoscience Australia acknowledges the traditional owners and custodians of country throughout Australia and acknowledges their continuing connection to land, waters and community. We pay our respects to the people, the cultures and the elders, past and present. So just a very quick background on the APREF project. The purpose of the APREF project is to create and maintain an accurate geodetic framework to meet the growing needs of industry, science and the public in the Asia Pacific region. APREF has served as an authoritative source of coordinates and velocities for geodetic stations in the region. It links the national and regional geodetic data to ITRF, densifies ITRF, and improves access to the ITRF. As of today, there are a total of more than 1,100 stations included in the APREF processing, including the IGS 20 core stations. The APREF products are available via the Geoscience Australia's Positioning Australia portal, including the long-term time series and the station residuals. IGS adopted its realization of the ITRF 2020 as IGS 20/IGS 20 Antex, November 2022, and APREF processing adopts the latest IGS standards, therefore adopting the IGS 20 frame. This included the daily and weekly solutions of APREF, where we use the Bernese software and we use the minimum constraint in the normal equation level to align to the IGS 20 core sites. This feeds into our legally traceable coordinates certification program called as Regulation 13, and also feeds then into the long-term and cumulative solutions where we use the catch-up software to do the minimum constraint using a set of IGS 20 core sites as a way to give access to the end users to the ITR, to the reference frame. We have an online positioning service called OSPOS, which we are also transitioning to ITRF 2020. So in terms of the cumulative solution, the alignment to the reference frame is done using a subset of the IGS 20 core sites, and these sites have been selected using a rigorous iterative approach with a few criteria. Only IGS core stations can be used. We try to do, to as much as possible, select one and only one station solution from each IGS 20 core cluster for the full period where possible. This hasn't been always possible though. 4 years coverage of the station solutions as a minimum, and residuals between the IGS 20 and the APREF solutions for these selected sites must be below 4 mm for the horizontal and 10 mm for the vertical component. This resulted in this set of 60 IGS core stations and 74 station solutions, depending on which segment in the time we are talking about. We also took this chance to, in adopting the ITRF 2020, to carry out a comprehensive review of our position and velocity discontinuities. For the IGS stations, we relied on the IGS list of discontinuities. For the other stations, we did this review using the available metadata, visual inspection analysis of the raw and detrended coordinate time series, and the statistical significance of the estimated offset. As a result, as you can see in the table, there have been more than 600 new discontinuities added and about 50 discontinuities removed from compared to the previous solutions that we have. In total, we have about 2,000 total number of discontinuities. For the velocities, by default, they are tightly constrained for each station at co-located sites, and linear velocities are estimated over time, where non-linearities are observed, we apply velocity discontinuities. So this is just the horizontal velocity field from as estimated with APREF. overall, nothing too surprising. Australia is still moving quite fast, between 5 to 7 centimeters. And we use this velocity estimation from the APREF cumulative solution to monitor our plate motion model, which in turn defines the geocentric datum of Australia and used for our legally traceable coordinates as well as other applications. Vertical velocity field, this has a particular importance for the Pacific countries because we provide support to our Pacific colleagues in terms of monitoring the vertical land motion of the Pacific Islands, and Ryan Roddick is giving a presentation on Thursday, so I'd encourage you to, on that program, and I'd encourage you to view that presentation. In terms of how APREF compares to the IGS 20, here the figures are the differences in positions and velocities compared to the IGS 20 core stations. Full IGS 20 SINEX, except for the solutions that have been less than 4 years. So with the solutions with short time spans, we have seen some large differences, which is probably due to the different data sets processed from the APREF or compared to the IGS 20 or other reasons. So in terms of the comparison to the selected datum, we are doing very well, and that's why we did that rigorous iterative approach to select those sites. In terms of the comparison to the full IGS 20, we still see some big differences, as you can also see in the maps. But when we remove those short solutions, we get about 2.5 millimeter horizontal difference and about 8 millimeter vertical difference as RMS. However, and also in terms of the velocities, it's 0.2, 0.3, and 0.7. However, this is the RMS, and in terms of the median, we don't see a significant systematic difference between the two. So I would say, apart from some of the solutions that are significantly different, there is no systematic bias seen. Also, in terms of the shape and the transformation parameters, we are doing very well with the selected data with the full IGS 20 solution. There's a bit of a scale issue, which also reflects in the vertical components mostly. So this is just an example of some of the issues that we encountered when adopting the ITRF 2020. One issue was the updated ground antenna calibrations as a result of multi-GNSS multi-frequency calibrations, where we had to implement offsets as a result of the switch to the IGS 20 antennas. This is an example in Western Australia, and the Zephyr Geodetic 2 triple antenna, which was one of the main largely active antenna types. In total, we had to add 147 offsets due to this update, and also 47 offset due to the previous update from IGB8 to the IGS 14 antennas. Other antenna types largely impacted included the LR10 and TRF57971. There were also other antenna types which were less impacted by this. Moving to the online positioning service that we have, called as OSPOS. As I said, we are also moving that, and we have been carrying out a comprehensive assessment of the new OSPOS version 3, which is in ITRF 2020 compared to the current operational one. And this is the result of the comparison between the two, using a set of about 25,000 RINEX files that were used for our national GNSS campaign archive. So we took that opportunity to use to test what happens. Essentially, the differences are this the scale is logarithmic, so the differences, the majority of differences are very small. 95% confidence interval is about 0.7 and 0.6 millimeter for the horizontal and about 2 millimeter for the vertical, with an RMS of 3, 2, and 14 millimeter for the 3 components. One thing of interest was this lump in the frequency histogram, where we, not surprisingly, found that that was mainly due to the same antenna type that we had seen the position changes as a result. So once we removed that antenna type from the experiment, that lump has disappeared. In conclusion, this was just to say that APREF has adopted ITLF 2020 as the latest available IGS standard with overall improvements made to the solution. Station position changes were observed up to a few millimeter horizontal and up to, in horizontal and up to about 3 centimeters sometimes in vertical with the switch, which were, a lot of them were caused by the updated ground antenna calibrations, but as had been communicated before from the IGS, also changes in the modeling could potentially have led to some differences and inconsistencies in the solutions. We are planning to carry out a full reprocessing of the history of the APREF data, which is expected to improve the consistency of the solutions over time. Currently, we have limitations and we have things to think about for future work. Enhanced time series and noise analysis, as was also discussed earlier, is in our vision. Experimenting with seasonal terms and hydrological modeling to improve the processing are some of the things that we currently are lacking, and would be nice to try them at least. And most importantly, we are transitioning to the GNSS software, which is our in-house GNSS processing software that has been developed recently for most of, or a lot of our operational activities. I will be giving a presentation on GNSS